Hello everyone, welcome back to our channel. So have you ever wondered how database actually store and manage data? So from simple hierarchical trees to the complex object-oriented approach, different models are used for different scenarios. But which one do you think is gonna fulfill your needs, and which one not? And when it is used, say we'll break down all the things like to know how which database model to use and which one not to use. So, welcome back to the fifth video of our data analytics series. And in this video, we'll explore four major database models, which are hierarchical, network, relational, and object oriented models. By the end of this video, you will know which model is best for different use cases. So, why it's important? Choosing the right model, affects database efficiency, speed, and scalability. So different models suit different industries: finance, healthcare, e-commerce, etc. So let's understand a little bit about the database model. So the database model is basically the structure and logic used to store and retrieve data. It's structure, you can say. So how data is stored, it's a structure basically. Like if you're building a house, right? So you will know like how to build a house, what are the things required, I mean what are the properties, what are the the basis and everything, right? So it defines how data is organized, related, and accessed. How everything is going on, it will tell you the database models. So this is what database model is. It tells how data is organized, related, and accessed. So what database models defines how data is organized, sorry, organized, accessed as well. I mean how you are accessing the data, and it is how it is related, means how it is related to the other data. So this all comes under database model defines it, how all these things are achieved. So there are four main types of database models that we are going to discuss, which are hierarchical, network, relational, and object oriented. So let's understand one by one. So the first one is hierarchical database model. So as you can see on your screen, so basically hierarchical model, as you can see this image over here, right? So this is hierarchical model, and this is root node. As for example, there is a parent and there are two children, right? The children one, and this will also have two children. So okay, sorry. So this is what hierarchical model, that parent node and child node. You might have learned data structure, tree data structure, right? So the hierarchical model is similar to a tree data structure. As you can see on this image, you will get a clarity over that. For example, this is a root node, right? And it has is of every, I mean, student name, student ID, John and Muskan. They can see the age and the everything, right? And also again they have the so many database and things. So this is how things goes. So now which database to choose and which not to choose again depends on your requirement, right? So as you can see, the structure data is organized in a tree like structure. This is hierarchical model. And parent child relationship, each child knows has a parent node. And data access, how data is accessed. So data, as you can see over here, how it is accessed, navigating through the hierarchy, right? So there should be some hierarchy of data. So this is what tree like data structure, right? So hierarchical model is tree-like data structure. Data is organized in a tree-like structure. So structure, as I showed you, right, and you can see over here as well, right? Tree-like structure it is, and one-to-many relation, because this one parent and so many children for one parent, right? One-to-many relation is hierarchical structure. And ideal applications means it is ideal for application with a clear hierarchy, such as organization chart. So as you can see, this also chat, it also reflects hierarchical database model. And limited flexibility in data is retrievable due to its rigid structure. So this is very rigid in nature, so it can be accessed, but there's a limitations of that. For example, one parent can or one child cannot have two parents in hierarchical data structure. So those type of problems you cannot solve with the help of this, right? Hierarchical data structure. So for that we'll discuss network data structure next on after this slide. So it comes up with the limitations of that. So this was all about this particular data structure. And now we'll discuss network model. I'm sorry, it was a model. So that was hierarchical model, and this is network model. So the network model is kind of it will fulfill the limitations of hierarchical data structure, because in hierarchical data structure what you can have one parent, and it can have different children, right? But here what you can have this type of structures. For example, this can have this parent also and this parent also, and even they can have multiple children, but so it can have many to many relation. But hierarchical had one to many relation, right? So this is what network model is. And as you can see, the model that allows multiple relationship between data, it will allow multiple many to many relations, many to many relations. So it's basically tells how DBMS, like you just let me make it more clear. Data model basically defines the structure of data. So these all whatever we are discussing, this network model, hierarchical model, this all defines the structure of data, how data is stored. It also defines how DBMS, which is database management system, store database access the help the database access the data, and also update it, how the database update with the help of data. So these all things are done with the help of database model. I mean, it all comes under database model, is how database is working. For example, how you are getting able to get the access of someone's personal informations, and how you are able to update, this all comes under the model. Like we'll make the model of our house, right? For example, a chat you will make, right? Before building a home, you will have an entire scenario, entire diagram, or the where kitchens used to be there, washroom is there, where room is there. So same database model is structure how data is present in the database. But not just that, it even tells, it even comes like how data is accessed, updated, it tells everything. So this all comes under database model. So now I think you are a little bit clear. So structure, it uses a graph structure with nodes and edges. So it has so many nodes and edges. These are the nodes and edges, right? These are the edges, these are the nodes. So this you can see are nodes, and these are the edges, and it's a graph structure. So it one child can have multiple parent node also. So it can be many to many relation, as you can see on the diagram, right? And even it can have like this. So this is based on graph data structure. So as you can see, data is represented as graph following multiple relationships, many to many relationships you can have in network model. And it records can have multiple parents, as I mentioned over, right? Enabling many to many relationships. So I already mentioned it can have one child can have more than one parent in network data model. So network data model solves many, the many drawbacks of the hierarchical model. For example, one product cannot be dependent on more than one product, but in network model it can be solved with the help of that. So you can take many real world example that we might be discussing further. So it's suitable for application requiring intricate relationship like telecommunication industry. So just now, like you can see that you can use these things in telecom industry. So that's what the limitations which was not possible in hierarchical database model. So this was all about this particular model. And examples, as you can see, integrated data stored and DVTG. So these are the one of the example of this particular database model. So now let's discuss the advantages of using these database models. For example, a hierarchical database model was like advantage was like fast data retrieval, right? When structure is known, because in hierarchical, the structure, you can access the data fast with a good speed. And that was good for the application with fixed predictiveness. For example, some relationship is fixed, right? So you know that, yeah, it is fixed, it's not going to increase or something, right? So you can, then hierarchical is used. But in other case, network model you will go with. For example, file system and IBM information management system was the example, can be the example of hierarchical data structure. But let's come to the network model. So in this, data is stored as a graph format, right, with multiple relationships. Unlike the hierarchical model, in hierarchical model it was tree data structure, like one to many. So here a child can have multiple parents, and it uses nodes and edges to represent relationships, right? And supports many to many relationship, as I already mentioned. So the advantage of using a network model, as I already told, it has advantages over the hierarchical model. So here more flexible than hierarchical databases, and also you can have a faster navigations for complex relationships. If the relationships are complex and you want to understand and find the entire data and access them, then you can do with the help of network model. You can arrange them in network model. I should say that will be the best term to call it. But there are some limitations of network model as well. The structure is very complex. Like it will look messy as many are having, as I told, right? So it's a very complex structure to get anything. So it is not as easy as a hierarchical data model. But use cases, let's see of that. Like as I already mentioned, telecommunication industry, right? Network and airline reservation system. Airline reservation system is also we use. Like you are doing reservation in airline, right? So multiple people are doing at simultaneously. So these are the example of network relationship model. So now let's discuss the relational model. So as you can see over your screen, a data is organized in tables and with rows. So in a relational database, it is stored in the form of table, as you can see on my screen. So you guys might have seen the Excel file, right? So it will be kind of in table, right? So it's like that. So in this, data is stored in form of table. So it can relate each other through foreign key. You might have heard in foreign key, primary key, right? Primary key, foreign key. So it's all, if you guys know that what's primary key and foreign key, you guys will get to know. So two or more databases, for example, there are two tables, right? So how can they relate it with them? How can you establish relationship with them? So you can just get it in easy way. So we use here a foreign key. It is the reference of the key present in the main table, which is primary key. So that's how it is used. So this is what foreign key is. And yeah, data is organized into tables, as I mentioned, rows and columns, and each table can be linked through with the help of foreign key. Foreign key is used for linking the two tables or related tables, right? So, and also it supports SQL. SQL means structured query language, right? We call it SQL as well. That will be coming to the next, in our next video. We'll go deep into the SQL with the help of hands-on queries also. So, and it is highly flexible, widely used in various applications for small to large databases. Because yeah, relational database, of course, it's used, highly used, one of the highly used one. But yeah, here only a structured thing you can use. You can only use your personal data or healthcare data or all that. So let's understand a little bit more. I mean, advantage of using this relational database. So it's highly flexible, of course, and scalable. Plus, it will support SQL, which is structured query language, for fetching the databases. And it is easy to modify as well without affecting the relationships. But there are some limitations of relational databases, which are, it cannot become slow when handling huge databases. I mean, if there is a very big data, no, then it will become slow. It will not work that fast speed. So that's the one of the limitations. And also it requires proper indexing for efficiency. If you miss some indexing things, then relational database might not work that properly. And use cases, as you can see, use cases of this is e-commerce company will use it because they have the data of the customers, and they want to what the customer wants to buy and what and all, everything is stored there in the database. So it is used in e-commerce, like Amazon, right? Amazon company, Flipkart, you might have known all that. So they use relational database model to store the data in the database. So now final we'll discuss, which is object oriented model. So this model, as you can see, it combines the database and object oriented programming. Database, name some object oriented programming languages. You might have heard of Java, Python, C++. Python, of course, we'll be discussing in this series as well. So these are some of the object oriented programming that we will be that you guys must be knowing if you have done program, if you are from a technical background. So that was all about this object oriented programming. But in object oriented not programming, I mean object oriented model, it is, data is stored as objects, like how in Python or Java or something, data is stored as objects, right? Similarly in this, it will store as object, as entity, right? We call it entity as well. Like for example, let's say home is there, right? So the data will be stored not directly. It will be like, okay, fan is there, one table is there, right? So these are the objects of house can be a class. So this is all like that. And the structure supports inheritance, polymorphism, and encapsulation, which are also the properties of OOPs. And when it is best, this object oriented model, so it is best for storing complex data types. If the data types are complex, then we use object oriented data model, and it reduces mismatch between programming object. There will not be any mismatch if you use this, but there are some of the limitations as well that we are going to discuss. So it's not widely supported as a relational database, not supported widely, and queries more complex than SQL. Query writing query for this particular object oriented is like kind of so lengthy and kind of a difficult process to do so. So we don't prefer much object oriented models. So use cases is are there. Some of the, for example, let's say multimedia databases, and CAD software you might have used in your computer, in your engineering or something. So this is based on object oriented model. So now let's yeah, this is all about object oriented development object, as I mentioned, and ideal for application kind data orientation such as CAD, the object DB, and all that. Real world example, it facilitates easier modeling of real world entities and relationships. So now you can see the comparisons of the model. So the comparison, as you can see over your screen, so you can see the structure of hierarchical is tree based, graph based, real table objects. Similarly, you can see all this, right? And you can, if you want me to share this PPT, I will definitely do that. I will share the drive link, and you can just access it from there. So do let me know in comment section if you want the particular PPT, and I will be happy to share. So this was all about the comparison. Go through this, and if you need any help, let me know. And comparison model I just discussed, right? So choosing the right model, how you can choose the right model, right? So what you will understand first, you will understand our requirement, and then we'll access complexity, we have to discuss, right? And then evaluating scalability, will the data grow over time? So we have to keep in mind all these things. And also we should consider technical skills, like will the data grow, can you manage a complex model or not? I mean, our technical level is there to manage or not, because as I mentioned, object oriented models are very lengthy and kind of very difficult to do implement. So example, let's discuss one by one. For example, for relational database, we can be like e-commerce. Similarly, we can tell for network model, we can go for like network model example is like social media, for example. Yeah, okay, okay, social media. Similarly, for object oriented enterprise software, as I mentioned, CAD, and yeah, that's it. And hierarchical model is basically best for parent child relationships. So let's summarize it. So basically, just understand that hierarchical model is best for fixed parent child relationships. On the other hand, network child handles complex many to many relationships, and relational model most widely used with flexible structured data. And last but not the least, object oriented model ideal for complex real world projects. So choosing the right database model depends on your project needs, and understanding these models will help you optimize performance and scalability. And that's it for this particular good videos. And like and share for more videos in this data analytics series. Drop a comment, which database model do you prefer, and why do you prefer that model, and what database model you have used till now. Also let us know in the comment section, and stay tuned for next video on SQL queries. And that's it for this. See you in the next video.